Hey guys, I'm back with more invertebrates. Today we are going to be looking at our annelids, and we are also going to be looking at our mollusks, specifically our bivalve. So the first one we are going to go ahead and look at today is going to be our dissection of a freshwater clam. So once again, this is a mollusk, and it is a bivalve because it has two valves. Each shell is called a valve. So the first thing we are going to go ahead and look at is the external anatomy. So one of the main road markers that we have to look at for identification is this little bump here. We got a bump here, we got a bump here. That is called the umbo. It's found on both of your valves. And then right along here, what connects the two valves, that is called your hinge ligament, and it helps it to hinge open. Now notice I already cut the adductor muscles on this. If not, you would not be able to go ahead and open it. I'm a bivalve. Okay, more external anatomy. So the side where we have the umbo here, this is dorsal, and then where it opens up as if it could speak to you like I just showed you, that's ventral. So once again, this is the ventral section of the valve. Here is the dorsal. Now anterior and posterior are a little bit trickier. So the way that we think of this is we go ahead and put something to mark right here by the umbo, and then we can determine anterior versus posterior. Now clams are kind of like Beyonce, they got a lot of junk in the trunk. So the larger side here, this is posterior, this side is anterior. So once again, clams have got a big booty, so lots of posterior, not a whole lot up in the front for the anterior. So once again, going over all the external anatomy, we have our umbo, hinge ligament, dorsal side, ventral side, posterior, anterior, and once again, this is a bivalve. There's one valve, there's two valves. Now the internal anatomy of a clam is pretty straightforward, not a whole lot going on. So we'll go ahead and open this guy up. When I went ahead and opened it, let me zoom just a little bit here, coming down, 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 there we go. You have these two muscles. This is what I had to go ahead and cut through. These are called the adductor muscles. Once again, they're labeled anterior and posterior. A little bit harder to tell, but right here, this is that bump for the umbo. So you've got the big section over here, so this would be your posterior adductor muscle. This would be your anterior adductor muscle. Now you can see I've got this little bit of tissue right here. It's also found more intact on this other side of the valve. Okay, this is the mantle. That's going to be what secretes the shell. Now when we go ahead and look inside the valve, you can see you've got this tough, you can't go ahead and feel it because obviously you can't touch through the computer screen. This isn't Wonka vision or anything. You've got a really hard, tough surface right there. That is going to be the foot. Okay, so you got to go ahead and look at where the foot is. So this is going to be what it sticks out, it allows it to move. And then for gas exchange, we're just going to go ahead and take this tissue aside for now. You can see a little bit of stomach contents in here. But right here we've got these structures. They lift up, they're almost feathery looking. I'll show you on the other side too. These are its gills. So this is what it's using for gas exchange. Up here you can see a little bit more of that posterior abductor muscle. If I go ahead and look over here, once again, this is that anterior adductor muscle. So when I go ahead and flip this over, you can see the gills, if that focuses really nice here. You can see they almost have a little bit of a striated complexion to them. They've got some little lines right here. That helps increase surface area for gas exchange. And then you also have a little set of flappies right here, kind of look like wings. These are the palps, okay? P-A-L-P-Y-S, maybe I spelled that right. Those are the palps. That is another structure that allows the clam to go ahead and just basically direct some more of activities as far as water flow and whatnot goes. So internal anatomy, not a whole lot we need to talk about there. Keep in mind right here is your mantle. You've got your gills. You've got your palps. You've got your foot. You have your anterior adductor muscle, and you have your posterior adductor muscle. So that's about all there is for the clam. We'll go ahead, put him aside. Goodbye. Now we got our worm. Okay, those of you that fish have seen these before. You've probably even baited your own hook. If you don't, well, we're not going to go ahead and make too much fun of you online. So let's see. There we go. Now we're focused. So a couple things with the external anatomy, we need to be aware of. This right here, when I was a kid, my dad always called this a sex ring. That is actually the incorrect term. It's called a clitellum. So that's going to be all about the reproductive activities of your worm. And then you've got the head region. This is the anterior portion. The anterior portion is always going to be the shorter section, closer to the clitellum. And then when you go ahead and get to the posterior section of a worm, see how it's flattened like this? That's another way that you can tell it's posterior versus the rounded edge of the anterior. So when you're fishing, if you only use half a worm, you'd want to use the tail section because it's flat. As it's moving through the water, it'll go ahead and cause more vibration. That's going to drive the fish crazy. So then we also need to go ahead and determine our dorsal versus our ventral. So notice how the worm on this side is dark, on this side is light. So think about it. These live in the ground. Their mucous membrane is what allows them to do gas exchange. So if it's up on the ground and little robin comes around, and it lands, it's trying to get food for its babies, which side is going to stand up more against dark soil? The light side or the dark side? Well, this is an adaptation that these earthworms have. They're dark on their backside. That is going to allow them to be slightly more camouflaged. So we know that this dark side right here is going to be, focus, I was talking to the camera, maybe you, maybe both. So this is the dorsal side, and then on this side you also have the ventral side. Another thing that if you were to go ahead and feel the worm, you can feel there's some rough kind of bristles. They're called setae. Those are going to be found only on the ventral side of the worm. That's what they use for movement. Also, you notice we have all these segments. Okay, remember that annelids are segmented worms. Remember here we've got our earthworm. Those are oligochaetes. So that's all the external anatomy we need to know. So now going to the internal. So to save time, I went ahead and opened up my worm here. I'm going to get nice and close so we can go through all the internal anatomy here. Hopefully this focuses a little bit better. There we go. I like it. Okay. So right here at the entrance, we're going to have the mouth. On the complete opposite end by posterior, we'd have the anus. Remember that your annelids here, they have a complete digestive system, so they don't have to go ahead and poop out of their mouth. They do have an anus. They have an intestine, which we'll identify in just a little bit too. So going from the mouth back, we have our mouth right here, then we have our pharynx. And then if we can just bring it down a little bit more. Let me see if I can get that just a little bit brighter. Oh yeah, I like it. Okay, you've got all these dark structures. Okay, these are called aortic arches. Okay, these are the hearts of the earthworm. Okay, so remember also that earthworms or annelids have a closed circulatory system. So these hearts go ahead and, as you can see, you've got a big vessel that goes right along the top here. This vessel is called the dorsal blood vessel. So your aortic arches, which are like your hearts, will go ahead and pump. They pump blood through this closed track, which is the dorsal blood vessel, to go ahead and supply oxygen and nutrients and then bring carbon dioxide back as well. Okay? So the next structure I want to draw your attention to are these white structures. Theoretically speaking, we would call them seminal vesicles, but all I want you to know that is that these guys right here, these are for reproduction for worms. So we're not going to go into talking about worm sexes or anything like that. Just know that these structures are important for reproduction. Now as we go back, you're going to notice we have one structure here, and then right behind it there's a lighter colored structure. Okay, this right here, kind of see how it's flexible when I poke it. It's real flexy there. That's its crop. So when the worm goes ahead and eats food, someone's knocking at my door. Hey, I'm taking a video. Can you come back in a little bit?
I'll just slide under the door.
Thank you. Ooh, turning in work, that's always great. So right here what we've got, this is our crop right here. And then right behind it, that is our gizzard. So if you know anything about birds, birds go ahead, they eat a bunch of food, but they don't have teeth, so they can't go ahead and crush it up. So they store their food in their crop, and then they go ahead and they crush it in their gizzard. The same thing with a worm. So then as you go a little bit farther back, in this one, you might just have to trust me with, but you can see it. It's right, let's see if I angle. Let's see if we can get in there. Now we're getting real close and personal. If it focuses, come on, don't fail me now, camera. Give it a tap. Give it another tap. Focus. Come on. Come on. Let's see if I put my probe down here, will it focus? Nope. Come on. Well, guess we're going to have to back it up there. That might be clear enough. So, right along, and you can barely see it, but if I lift this structure that I'm lifting right here, this is the intestine. I only dissected to the clitellum. Everything behind here is basically just intestine. But if I move the intestine, do you see how there's that little white band? Let me see if I can do this a little bit with my thumb. If I move that, you can see there's this structure right here. Okay, it's moving throughout the worm. This right here, this is the nerve cord. So that's going to be basically sending responses throughout the worm. That's going to be on the ventral side. It goes ahead and is going to send messages. The worm does have a very small, we would call it a brain, but it's actually ganglia way up here. But that nerve cord right here is what transmits those electrical impulses back and forth throughout the worm. So going now from back to front, we've got our nerve cord. Right here, this tube is our intestine. On top of the intestine right here, this dark cord, or I should say this dark vessel, that's the dorsal blood vessel running all the way through. Then we have our gizzard right here, this lighter shaded organ. Then here we've got our crop, we've got our reproductive organs, we have our aortic arches right here, and then we have our pharynx. And that is just about it for the internal anatomy of a worm. So if you missed the dissections today, make sure that you watch the video, because this is the information that you are going to have to be able to identify with both your annelids and also your bivalves. Thanks for watching.